So in this problem, we need to determine the equation of a parabola with vertex having coordinates 2, 3. Its axis is going to be parallel to the y-axis and passes through the point 4, 5. Let us begin. We'll try to understand the problem graphically. To begin with, we are considering a vertical line such that it is parallel to the y-axis. Now on this vertical line, we're going to consider a point. Let's call it the point V. V is going to be the vertex of the parabola and its coordinates are 2, 3. Now, we are going to consider a upward facing parabola. That means we have the parabola of the shape which is facing upwards. Now, this particular parabola is chosen such that the focus, we're going to assume that the focus has the coordinates 2, f. Now here the x coordinate is going to stay as 2, where that's obtained from the x coordinate of the vertex because it lies on the same line. Now on this line is referred to as the axis of symmetry line. So on the axis, we are going to consider a third point. Let's call it point A. Its x coordinate is going to be stay fixed at 2, but we don't know the y coordinate, so we're going to consider it to be b for the time being, but we'll try to express it in terms of f. So here the point A is chosen in such a way such that the distance of point A from the vertex, so this particular length, is exactly equals to the length of the focus from the vertex. So this length will be exactly equals, and we're going to pass a line through this point A, and it's going to be perpendicular to the axis of the parabola. So this line is known as the directrix of the parabola. Let's try to find out the value of b in terms of f. Now here, v is the midpoint of the line segment joining point A and point F. That means we can use the coordinates of point A and point F to define the coordinates of v using the midpoint formula. So that means the x coordinate is going to be 2 plus 2 divided by 2. All we have done is added the x coordinate of point A and point F and divided it by 2. For the y coordinate, we're going to take the sum of the y coordinates of point A and point F. So we are adding b with f and dividing it by 2. And this is going to be equals to the coordinate of the vertex which is given to us. So that's 2, 3. Now we can equate it. So here the x coordinate is going to stay fixed as 2. All we have to do is equate b plus f over 2 equals to 3, which implies b plus f will be equals to 6. Now what we need, we want to express b in terms of the y coordinate of the focus. So that means b can be expressed as 6 minus f. That means the coordinates of point A will be 2, 6 minus f. Now that we have the coordinates of point A expressed in terms of f, then we can define the equation of the directrix. The equation of the directrix that's parallel to the x-axis. We know any line which is parallel to the x-axis is given by y equals to b. So here b is going to correspond to the y coordinate of point A through which the directrix line passes. So that means b is 6 minus f. So we can say y will be equals to 6 minus f. That's going to be the equation of the directrix. So let's try to write y equals to 6 minus f in the general form of a line, the general form which is given by ax plus by plus c equals to 0. So here we don't have any x term, so we can rewrite it as 0 times x added to 1 multiplied to y plus f minus 6. This is the constant term. This will be equals to 0, and that's the equation of the directrix. Now, in the problem, it's given here that the parabola passes through the point 4, 5. So let's say the point is defined by P with coordinates 4, 5. This means that by definition, if we join point P and point F, and from point P, if we drop a perpendicular on the directrix line meeting it at M, then by definition of a parabola, the length PF should be equals to PM. Okay, now we can find out the length PF. So PF will be given by the square root of, so we have to take the difference of the x coordinate. So here we have 2 minus 4 whole square. added to difference of the y coordinate will be f minus 5 whole square. But this will be equals to Pm. Now, Pm is the perpendicular distance of point P from the direct straight line. So here we'll be using a formula. Let's say we have a point with coordinates x1, y1. Then we have a straight line which is given by the equation ax plus by plus c equals to 0. Now from this point, if we drop a perpendicular line on the straight line, then this perpendicular distance d will be given by the absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. So here we'll use this formula. We'll take the absolute value. So here we'll have to take the ratio. We'll start with the coefficient of x, that's 0. 0 gets multiplied to the x coordinate of point P. So that's going to be 4. So we have 0 times 4 added to, we need 1. 1 will be the coefficient of y, that's multiplied to the y coordinate of point P. So that's 5. And then we have the constant term, that's f minus 6 divided by the square root of, so here we'll have to take the sum of the squares of the coefficient of x and y. So we have 0 squared plus 1 squared. So let's simplify this. We're going to get square root of, so 2 minus 4 whole squared, that's going to be positive 4 added to f squared minus 10f plus 25. So this will be equals to the absolute value of f minus 1 and divided by 1. So further simplification is going to give us, so we'll square both sides. So we have f squared minus 10f plus 29 equals to f minus 1 whole square. So f squared will be f squared minus 10f plus 29. That's equals to f minus 1 whole square. That gives us f squared minus 2f plus 1. So here we can cancel out f squared from both sides. And we can combine negative 10f and negative 2f to get 8f. This will be equals to 29 minus 1, that's 28. So f will be equals to 7 over 2. So we have successfully obtained the value of f. So that means rewrite the equation of the directrix line as well as the coordinates of the focus. So we use the value of f as 7 over 2. That gives us the coordinate of the focus at 2, 7 over 2. And the equation of the directrix now changes to 0 times x plus 2y minus 5 equals to 0. Now we can finally find out the equation of the parabola. What we'll do, we're going to consider a general point on the parabola. Let's say that the point P prime. So P prime has the coordinates x, y. We use the same logic. So if we join point P and point F and drop a perpendicular from point P prime on the directrix line, meeting it at M prime, then by definition, again we can say by definition, we can say that P prime F must be equals to P prime M prime. So P prime M F can be obtained by using the distance formula. So this time we will get x minus 2 whole squared added to y minus 7 over 2 whole square equals to P prime M prime. So that's going to be the absolute value. So here we'll start with the coefficient of x, that's 0. 0 gets multiplied to the x coordinate of P prime added to coefficient of y, that's 2. 2 gets multiplied to the y coordinate of P prime. We have the constant term negative 5 divided by the square root of 0 squared plus 2 squared. So here I'm leaving this as an exercise for you to simplify. So the final result will be x squared minus 4x minus 2y plus 10 equals to 0. And this is going to be the required equation of the parabola that we needed to obtain.